Hey there guys, this is Tom, back with another physics video. This week's one is on the range of a projectile in motion. So let's hop straight into it. This week we were provided with a lovely little Lego projectile launcher and told that we could only fire it straight up to calculate its launch velocity. So that's going to be a calculation down here. We were told then that we were also going to later on fire it at an angle, at an object a certain distance away, this guy, and we had to figure out exactly how to get it at that stage. So, breaking all of this stuff down, we know the velocity in the x direction isn't going to be changing because there isn't going to be an accelerating force after it's been fired. So based on that, the change in time is going to be equal to, rearranging that, the distance it travels along the x-axis divided by the velocity. Now, Vy, final, the final velocity of the object is going to be equal to the initial time plus the change in time times the accelerating force. When y is equal to 0 though, the final velocity travelling downwards is going to be equal to the initial velocity travelling upwards, so negative yi. Because of that, we can substitute those guys into this, along with this over here, to give us that. Rearranging that, you get change in time here. Stick those two together, incorporating the x component for the cosine, and you get this. Rearranging that using a lovely little trigonometric identity of 2 sine theta cosine theta, you get sine 2 theta v squared negative over a. Now, we then did the calculation for our projectile initial launch speed, and we used the half at squared thing to work out exactly how far used how far it was travelling to work out half at squared and all of that stuff to give us velocity. Rearranging these two, we get this. Substituting that in up here, you get 2AD divided by A, so 2D sine 2 theta is equal to the distance it travels. We've got to change the signs on this because this is y at 9.8 in the negative direction. Those two cancel out because this is just a magnitude. So that gives us that. Next, we designed our projectile shooter. Obviously, we have the original shooter up here. We attached it to a couple of little bars and then tried to use a protractor to measure the angle that we were firing at. We noticed there was a problem with it. The hinge tends to move a fair bit, which throws out our angle. At the same time, the protractor is not very good at measuring the angle in such a confined little space. So unfortunately, we decided it wasn't good enough. We moved from there to extending the length of the firing mechanism lever, which acts up here. That removes the likelihood of the hinge moving as opposed to the firing mechanism, because the point of leverage is now up here as opposed to the length of that length, as you can see from down there. Then we tried to work out how to improve on the protractor, and we came across trigonometry. So, because LEGO uses 90-degree angles everywhere, we set a 90-degree angle in place, then used an x length of LEGO and a y height of LEGO, and using tan theta is equal to y over x, thanks to, SOHCAHTOA, whatever you want to call it, we can change the shape of these, change the length of them, to adjust our angle. We then also added a locking connector in this little joint here, just to prevent any hinge movement and keep the angle stable. So we were then told we had to fire at 1.63 meters. We then divided that distance by the initial velocity, or rather the maximum range, to give us this. And then do all of this, so sine to the negative 1 of that, which is now a number less than 0, but greater than, less than 1, greater than 0. We get and that gives us two firing solutions, 65.31 degrees or 24.68 degrees. We then used the tan of the angles to figure out which one would be more useful. Decided B was worse because on this angle there is more leverage thanks to gravity on this point than if it was up here, and we don't want that leverage because it causes a slight change in the hinge. So we decided to go with 65.31 degrees, fired the projectile, and moving on to the results, it worked! The end! Thanks for watching.